Hello, thank you for coming. I appreciate you guys all taking time out of your day, and hope you're having a good PuppetConf and you've enjoyed lunch, and you're ready for us to tell you a bit about our experiences working with Puppet and how we've integrated into our product, and give you some background and hopefully give you a little bit of new information and some new ideas. So we've had a bit of technical difficulties. I apologize. I can't get this out of presentation mode, and it's a bit difficult for me to read, so just bear with me here. So first, let me tell you a bit about myself. So my name is Keith Chambers, and I've worked at Cisco for 13 years or so quite a while. I started at Cisco in our technical support group, and I worked there for about 7 years. And that's similar from my perspective to being in the operations world. So you got a good opportunity to see what worked, what didn't work, and you can't really unlearn those things that you learn in that sort of role. From there, I moved into product management, product marketing, and I was working on a voicemail product, and I really quickly decided that product marketing and product management wasn't for me. Looking across the industry at different competing voicemail products and how you're going to compete with them was not a very interesting thing. But we took that product and we virtualized it, and it was a great learning experience for me. And it helped me to kind of build onto my next role. So after working there, or in that team, I was fortunate to move to a new project that was being created called WebEx Social. And I became the platform architect for that product. And it's been an interesting 4 years of working on it, and I'm proud of our time there, and want to share that story. In general, I'd say that I'm very, very passionate about technology. I'm always reading and researching how to do things better. I'm passionate about people and the end user experience. I'm particularly passionate about people who you meet in your career and the people that you work with. And I think that it's a critical ingredient to having any sort of successful team is the people. And then I'm always looking to raise the bar, and we've done some of that along the way. This is a quick little bio I put together for Ryan. Ryan's down here in the front row, and after I'm done explaining or kind of walking through some of the overview of what we did and the decisions that we made along the way, Ryan's going to come up here and give you a practical demonstration of some of the newer ideas that we have and some of the patterns, and we'll have some code to share as well. But so Ryan's worked at Cisco for 3 years now. I actually found Ryan, I found him through his blog, and I'm not a recruiter or anything, but I did have an open rec. So I called Ryan, and I felt like I was calling a girl on a date, because I've never done this before. And I didn't even know how to start talking with him. But I kind of told him about the group we were working in. I asked him, where he was at and what he was making when we could meet that. Got him to interview, and it all worked out. And he came over, and really grateful that I found Ryan and that he came over to Cisco. So he's worked here for 3 years as a software engineer, and he's played a really critical role in what I'm going to talk about. Previous to that, Ryan worked at a managed host provider. This is where we hired him out of. There he had to build the infrastructure, and not only did he have to build it, he had to support everything he built. And again, I don't think you can unlearn those lessons. In fact, there have been times where I've suggested ideas to Ryan, and he said, yeah, I thought that was a good idea too until I tried it. So very grateful for his past experience. And Ryan now has been a user of Puppet for 6 years, so he has quite a bit of experience there. So I'm going to go into a quick overview of the product that I've worked on. I'm going to talk about the experience from the customer or the administrator's perspective. Then I'm going to go into the plumbing of the system, which I think will be most interesting for this audience. And I'm going to talk through the history and evolution of the product, because there are 3 or 4 years involved here, and I think it's important for people to understand where we started, how we moved to where we're at, and candidly the lessons learned, the mistakes that we made along the way. I think I've learned a lot, and I think others will hopefully too. And then we have some real simple secrets to our success, which is the title of this, so I had to throw that in. And then from there, we'll move on to Ryan demonstrating a few things. So quick overview here of the product itself. Kind of ironically, I don't have to spend that much time on the top piece of the product because, I guess I've more focused my time on the underlying platform and infrastructure and how we glue all that together. So I don't have a whole lot on it, but WebEx Social is an enterprise social media product. You could kind of loosely describe it as Facebook for your company. So end users can create content on the system. You can have communities of end users where they can share content with each other. You can follow coworkers, kind of like friends, but it can be a one-way type thing. You can like different content. You have an activity feed similar to Facebook where different events that are going on in the system get delivered to you based on what your likes and preferences are. And then we can do recommendations, recommend users, things like that. So, so those are kind of the basic capabilities of the product. I think what's interesting about it is the product is delivered in two different flavors. So there's an on-premise offering where we actually deliver this to the customer, and the customer runs it at their facility in their data center, which is a little bit different than working at a startup where you can, break something quickly, push a change. You have to have a little bit more rigor when you're handing something like that off to the customer, and it may be out there for a couple months, a couple years, who knows. So we started with the on-premise deployment model, and then over time we also added on a cloud-hosted model. So the product itself has a very traditional web architecture where we have multiple different tiers in the service. We have a large number of services, which is this kind of goes into the area that we've been working on. So we have an application server. We also have a worker. This does kind of back-end batch jobs, so coming up with the recommendations for users, things like that. We have a lot of modern tools. We have OpenFire, which is an XMPP server for pushing notifications to users. We have RabbitMQ. We have Memcached. We have MongoDB, and we have two different replica sets of MongoDB in our cluster deployment. We have one that's used for the kind of the real-time data, or what the user is accessing when they're making a request. And then we have one that's used for our analytics, so we do MapReduce jobs against it. The product also has Oracle, the Oracle database in it, 11G, R2. And we have Solar, and we use Solar for a couple different functionalities, traditional search, and then part of how we deliver the activities feed. So there's, if you just start counting on the technologies, there's a lot of different technologies involved, and then we have a lot of different, we reuse some of those technologies for different types of features of the product. So there begins to be a lot going on there in the system. So the 10,000-foot view of the system, so we deliver the product in a virtual appliance form factor, so an OVA. We have a roles-based architecture. That's the name that we call it, a roles-based architecture, where we have one service per VM. So we don't try to optimize on the virtual machine count. That gives us the ability to do quality of service and that sort of stuff at the virtual machine level, and it kind of simplifies things. So we have one service per VM. We don't optimize the count. A typical deployment could have 25 or so different virtual machines. And in the beginning, we knew this would be a challenge with customers 4 years ago when we started, because customers, enterprise customers at that point in time were considering virtualization and consolidation, and they would often count how many servers were involved. And it's still a bit of a challenge today, but people count how many machines are there, and then they roughly equate that to how much work is going to be involved with managing the system. And so what we wanted to do is to help to move people past that. And so we came up with this idea of having a director, or that's what we called it. It's really just the idea of a controller, a single point of administration of the system. So whether the system has 10 machines, the minimum footprint, or 50 machines, the amount of work that's required to manage the system should be the same. And I think this holds true for other services out there, that you want to be able to scale, grow out the service horizontally and not have to scale your administrative overhead in managing that service at the same time. So we have this idea of a director. It's loosely equivalent to VMware's Virtual Center. That's a very popular one that's out there. And more you're seeing different projects up where people have this idea of a centralized point of control for another service, or for the whole system of services. And then the other key idea that we had is we wanted everything to just work right out of the box. So the customer didn't have to configure all this stuff to get it working. So the deployment experience from the customer's perspective. So the customer they would start by downloading an OVA file from Cisco.com. The customer would then deploy out the director VM from that OVA. And I don't know if you guys are going to be able to see this, but within an OVA, you can specify different configurations. And this is, you're basically saying how many CPUs, how much RAM, how many NICs, what's the geometry of the hard drive going to look like. You can define different configurations. And so for each one of our different roles, we created a different configuration. That way the customer didn't need to download a different image for each machine, or we didn't have to have them go in and manually deploy a machine and then set the parameters. So this helped to kind of simplify that for the customer. So they start by deploying out their director. Just set the network settings for it on the console. It comes up, the director node comes up, and now the customer can browse to the user interface where they can do configuration of the system, and they can define what the topology for the system is going to be. So a couple screen captures here. I hope you guys can see these. So this is what our director user interface looks like, and this is the configuration screen that I'm showing here. So this has common settings that would apply across all the different machines. We have them all in one location. There's a few more different sections here, but we try to keep it to a minimum. So for example, we have memcached, but you don't have to configure how much RAM memcached is going to use. On boot, we have it designed where it looks and says how much RAM is in my virtual machine, and then it takes 256 megs away from it, and that's how much it configures itself to use. So we wanted to make it so the customer has to define the bare minimum possible to get the system up and running. So this is where they would do basic configuration that's required. And then this is where they would go and add virtual machines to the system. So you would need to select the role that you want to have that machine use. And you need to specify the fully qualified domain name that it's going to use. So the next step is that the customer is going to go and actually deploy those virtual machines that they defined in their topology. So we were not deploying the virtual machines for the customer. There was concern that enterprise customers would not actually give us API access to VMware. And so that was kind of the reasoning there. So deploy out the machines, start them up, and give them the network settings that they require, point them at the director, and then from there, the system would automatically deploy and configure itself. OK, so that was the deployment. Now the customer has been running the system for some period of time, and they want to upgrade. So for this, we had, again, since we were not orchestrating the virtual machines, we're not doing it, we didn't want the customers to have to go in and replace all the machines to do an upgrade. So we wanted to do an in-place upgrade. So we came up with this idea that the customer would download a single image file from us that would have the new release software in it. The customer would upload this file to our director node, Once they've done that, they would click a single button, which is to do an upgrade. So the customer clicks upgrade. And then once again, from there, the system would handle the upgrade for them. The customer wouldn't have to go into MongoDB and install the new version there and then go over to RabbitMQ and do this. We wanted the whole thing to be contained and really simple from the customer's perspective. So now let's talk a bit about the plumbing, like what's actually going on underneath here. Because at this point, you probably can't see what technology we're actually using. And I am just noticing we have a slide out of order, a couple slides. We'll go to the plumbing in a second. Staying inside of the director, this is what our page looks like for health of the system, where you would go and check to see if the system is healthy and running, where you could go to download logs from the system. And one more out of place here. This is where you would go to monitor the performance of the system or any sort of metrics. And again, this was all baked into the system right out of the box, already set up. You didn't have to go in and add monitoring or add the performance, performance metrics. It was all just in there and outside it and working right out of the box. Additional functionality that we had here that we added later was the ability to do a scripted deployment of the system. Here we used OVF properties so that you didn't have to log onto the machine and actually put in the network settings. We could just read them directly into the machine. So here I'm showing the network settings, the address for the director, those getting pushed in through the OVF, and then you having some sort of glue code inside of the machine which applied it. And then finally, we had a RESTful API for programmatic management of the system. So the director itself had a RESTful API. Okay, now we're getting into the plumbing. Sorry about that. So under the covers, our director, so first off, we're packaging everything as an RPM. So all of our software, Mongo, Solar, etc., all packaged as an RPM. And our director node is our Yum repository as well. And this was a bit confusing for people to understand, but there is no additional Yum repository that we also go to. Our machines are configured to use the Yum repository that's on our director node. So RPM and Yum there. And then our director node is also a Puppet master, or it is the Puppet master for our system. So let's talk about what this release image looks like a bit. So this is a version build artifact. So in every new build of the product, we create a new one of these images. And under the covers, it's an ISO, but we originally called it a .iso, and that was confusing for people. So we changed that to being a .img. And it has all of our RPMs for the release, and it has our Puppet manifest for the release. And so you upload this image to our director node. And when you choose to do that upgrade, we unmount the old image, and we mount the new one. So there's not a lot of machinery in there. It's very simple. And then we essentially call Puppet run, we call Puppet run across the nodes, which does our upgrade. And the feedback mechanism that we have to know that that has worked is at the end of it, we write a version number to the system, to the hard disk, and we use salt to go and fetch that version number and display it back in the user interface. Other things that we have under the covers, so we have this, you saw that there was a user interface where you can go and get the logs. So there we are just having all the machines either directly write their logs to syslog, our syslog, or we have our syslog going and scooping up the logs and forwarding them to the backend. But under the covers, this is what we're using for our log transport. We did some performance testing on our syslog. It's very high performance. It could do something like 1.1 million messages per second. In fact, we found it to be faster than Scribe. So I know that a lot of times people look at those tools and think that they are the latest and greatest, but honestly, our syslog has very impressive performance. It's been very reliable, and it's right out of the box with CentOS 6, which is our distribution. So it was a really easy choice for us. The monitoring, we are using Nagios. Some of this gets kind of boring, and unfortunately, I think that's part of the idea. But we're using proven, reliable tools. So we're using Nagios underneath. You can get RPMs for it right out of EPEL, and since we're using CentOS, that's simple for us. So we have we have Nagios going and pulling Monet, which runs on all of the different machines, to get the state of the system. So we're not using NRPE, we're just using Nagios as that central brain, so to speak. And again, Monet is just a very simple, reliable tool. It's very, very flexible. And you can also do some self-healing type things. So if a process isn't running, you can restart it. I'm sure you guys have worked with it or heard of it before, but it's again, just another nice, simple tool that we've been using in our system. So for our metrics, we have, again, another couple tools that are becoming more and more popular. So we have Graphite, and we have CollectD. So all the hosts send their statistics back to Graphite, and we just use its API for rendering them. OK, so a bit of history of this evolution, and this is where I am going to have to read from up here. So in the first phase, when we did our release, we did not have Puppet. We didn't package a lot of things as RPMs. We had a very short amount of time that we were asked to get a product to market, and we didn't have any DevOps tool experience. And 4 years ago, I would say that, I don't know that the term DevOps was there, but we didn't have experience on the team. We had a really short amount of time, and we just kind of had to go. And so we created a lot of proprietary tools. We were installing all of the software on all of our virtual machines. And you can imagine that when you're telling a customer you're going to need 25 of them, that could be an issue for them, a very large footprint. We had a very monolithic monitoring product in there. And so we got our solution out to market, but it was very, very brittle. And I was really concerned that it wasn't going to scale to a larger customer base. And there was a lot involved with maintaining it because we built our own tools. So this was the first phase of the evolution for us. So in this second phase, this is when Ryan came over to Cisco. And he was really the one that pushed first to do Puppet. And being the new guy, I wanted to understand it, but there was some concern too, because we didn't have expertise in the team. And it was a high-focus product, and it was viewed as being risky from a management perspective. This is prior to Cisco investing in Puppet. Ripping anything out is a concern, and it was a big concern. And honestly, it was a gamble at the time for me. I put my faith in Ryan, and it did work out. But so we went to packaging everything as RPMs and using Yum. We put in our Puppet master model. We went with this release image, and we reduced the virtual machine footprint. Because now that we had Puppet in place, we only had to install the software that we actually needed on the machines. We didn't have to install everything. And so there was a major backlash once we actually put this in as well. QAs and developers love to get into the systems. They love to make changes. And Puppet would come along every 30 minutes and wipe out their changes. And for a couple months, I would say, they were pretty dark days. Ryan being new and being the guy that was implementing it, I don't think he talked to anyone. I know that weekly I talked to my manager trying to articulate the value of why we were replacing what was perceived to already work. So there was some challenges there with implementing this from a human perspective. But ultimately that worked out, and then we moved on to adding more capabilities. So we had this hosted model that came up. And so Ryan actually, again, he added our director REST API in a weekend without really needing to be asked. So he added that. I worked on this OVF properties so that you could launch the machines or something could do a programmatic deployment. We unified our logging. Initially, we had it going to NFS and various different places, and so we got them all into a couple tools. In the beginning, there was a lot of concern about our syslog, just based on name association with syslog. There was concern that it would be slow performing. But again, we built on this success, and you can see here that Puppet isn't really mentioned. At this point, we were using Puppet to implement this, and Puppet was essentially a done solution for us. I don't want to say done because you continue to improve things, but it was in there, it was reliable, and now it was enabling us to do these next steps, things we could have never, ever done before had we not had that level of control. So we took Puppet to the edge, I would say, in our next release. Again, remember, we're not getting rid of the virtual machines. We're upgrading them in place. And Red Hat does not support an upgrade from Red Hat Enterprise Linux 6 or 5 to 6. And we were able to do that with Puppet gymnastics, I would say. But we upgraded those systems that were out there in place from CentOS 5 to 6. We started layering on things like Monet and Salt. We removed Scribe because we had more confidence in our syslog, and we wanted to generally reduce the amount of packages and libraries that we were bundling. And we started down the process of replacing our monitoring system with a loosely coupled set of tools, like I had showed earlier. So just one thing here, because I've heard a couple people in my, continue to bring up Salt, and I'm probably not. So just when we first added Salt, we did it really quick. We'd had a great experience with Puppet. We assumed that was going to be the exact same experience. And it proved out to be buggy for us. We were only using it in a limited use case, and that was good. This was a couple years ago. That doesn't mean that's what the experience is going to be now. So this isn't me talking bad about one single tool. But it's more like you need to look at more than just, are they getting a lot of commits on GitHub, or do you see a lot of slide decks around it? You need to evaluate the tools, or at least in the situation that I was in, we needed to really evaluate the tools and to pick tools that were stable, reliable, and that we could trust. So then moving on here, we put in Graphite, and at about this time, we had done so much changing in our system with Puppet that we started to get spaghetti in our code, essentially. We had so much, ensure that this is not installed, ensure that this directory is not there, ensure that this is not, that we started to have a more difficult time to manage our code base. And that's kind of shaped some of our forward-looking ideas for how we would, if we could redo it, how would we redo it? And the other phenomenon that we had is that different products at Cisco looked at what we were doing and wanted to emulate that pattern. And so the first question was, where can we get your code? How can we start, can we start from what you have? And we realized you couldn't. We were built too much for our one single product. And so this idea of more of a generic controller came up. And so that's what we have been working on since then, is a generic programmable controller where you feed in a model of the service of what you need, and that programs the controller to actually be a controller for that service. We are moving towards a model where we will deploy our virtual machines against the API that's provided by the infrastructure, whether that's OpenStack or VMware or whatever, where we're going to programmatically control those machines. And we like the approach of using a tool like Fabric to do your deploy, to do your upgrade. What we were missing was a stepped workflow. Our deployments were just too complicated to not have that. So we think that that's a very important thing. We like the idea of baking virtual machine images and replacing them on upgrade. We think that we've experienced that it dramatically reduces the size of our Puppet code base. And a lot of the gymnastics that we have to do and then have to deal with the maintenance of that code long term, we just don't have to when we're replacing the virtual machines. So we think that's a powerful pattern. And then we like externalizing module parameters with Hira. So kind of to wrap it up here for my piece, and then Ryan's going to show a couple things. These are not unique ideas, but they're things that have proved to be valuable, or they're the things that I believe at this point very much, and the lessons I've learned kind of shape this. But that Unix toolchain pattern where you select best-of-breed tools and you loosely couple them together and you have the ability to replace them is key to being able to iterating. And you should not select broad, tightly coupled solutions if you think you want to do changes. And an example of this was with Graphite. We were going to go with an RRD-based solution. I was looking at Graphite. I was trying to gauge whether it was going to be a viable product. Again, or a viable open source project. Again, this is a couple years ago. And because we were loosely coupled and we weren't going with like a Nagios NRPE, do it all for us, we had that flexibility to adjust. And it ended up being very, very powerful in working with those enterprise customers. Having a REST API so they could query for whatever data they wanted to understand the system was very, very powerful. And that loose coupling enabled that. Keep things really simple. Whenever we have implemented things because I thought we would need in the future, we have not, almost every single time. Defer implementation until you truly need it. Don't over-optimize. I was looking at reducing the virtual machine footprint, and we got it down to 300 megs, and then I thought it was a good idea to get it down to 200 by pruning out kernel modules and documentation, and there was diminishing return on investment. We had gone from 20 gigs to 300 megs. That was good enough. We should have left it there, and we added complexity because we didn't stop there. So that 80-20 rule. And then just the learning and adapting. You cannot fall in love with what you've created yesterday. If you fall in love with what you created yesterday and you have emotional, you're emotionally tied to it, it's going to cloud your vision. It's going to cloud your decision to move to something that makes more sense for you now. So it's really critical to be proud of what you've done in the past, but be willing to build something better or replace it. Our perspectives on Puppet. So it's an excellent configuration management tool. We're very, very pleased with it. I talk about loosely coupled tools. I think that we should implement it in a way where we could switch it out if it wasn't the right solution for us in the future, but that's definitely not the case. We're very, very pleased with Puppet. It's gaining an adoption across Cisco. Reinhardt's here speaking on behalf of Puppet as well, and it's a great tool. We're really pleased with it. Bulletproof reliability, it just has not been a problem for us. Long-term investment protection, if you just look at how many people are here, you can see there's a strong community behind it. And the product is going to continue to be there. It's not something where you have to worry that it's going to peter out, that the project is not viable. There's a company behind it. It's moving forward. Strong ecosystem. And then their true commitment to open source. And by this I mean that we have found issues with Puppet. I know I said it's been bulletproof, but little things where it was changing permissions on some files, and we submitted a patch, and they accepted the patch, which sounds like a very small thing, but you'd be surprised how many projects don't do that. They're open source, but they're not truly integrating those things. It's surprising how many. So we feel very, very good about Puppet, and that's why we're here, and it's a safe, reliable choice. And I promised Alex Sonner that I would give him a plug because he's been extremely helpful to me. So he started a new project, Simplify Ops, and he's kind of the lead behind Rundeck. I was fortunate enough to work with him, and he led some work that we did. He's a walking encyclopedia of proven patterns, and he's been kind enough to always pick up the phone when I have those really, really hard problems. And Ryan, with that. Oops. Thank you guys very much.
My name is Ryan Huber. Is this on? Oops, sorry. So now that Keith has talked a bit about more of the architectural things that we've gone through at Cisco with Puppet, I'll give a couple of small examples of patterns that have worked for us and a couple of small pieces of tooling that we've created around some common tasks. So some of the things I'll cover is how we install Puppet code onto systems, how we manage machines using Puppet, what we're going to actually write in those manifests and how we handle that, installing software packages and how we maintain that throughout the life cycle of a system, and how we maintain confidence in the systems that we've already deployed. So we, as Keith has mentioned, we package everything as RPMs, including the Puppet modules themselves. And this actually, it sounds like a pretty simple thing, but it really gives us a lot. RPM complements Puppet with a number of things. The first being versioning. We've seen people do versioning inside of Puppet modules using namespacing, other things like that, but we get this for free with RPM just because the RPM is versioned itself. It gives us verification because RPM has a built-in verify option that you can use to verify checksums, timestamps, and different things like that on the files that the RPM is installed. We can upgrade and remove Puppet modules easily using RPM and yum. And the dependencies. So if, say I had a Puppet module that was configuring the cron daemon, I can declare that this RPM that has the module in it depends on cron d. And that's how we can, make sure that that's installed before we actually try running the module. We don't need to install the software with Puppet itself. So this is just an example package name that's up here at the top of this little slide. So we sort of namespace all of the RPMs that we have that contain runnable Puppet module code with this CFG mod prefix. It's really just a convention that we use. It's not required or mandatory. We don't parse it or anything like that. It's more just for the convention. But each module performs a small task. I think that Keith hit on this a little bit with the Unix toolchain approach. And they're highly reusable, which is really important to us because we have so many different groups at Cisco that are writing things using Puppet, and we don't want to have to implement, say, like the cron D solution 15 different times for all these different groups to use. So by keeping these modules single purpose and very focused, not everybody has to go and write their own. And so Adrian Thabo actually kind of hit on this a little bit in one of his publications called Configuration Management as Legos. And so he talks about these reusable modules as the rectangular pieces of Lego blocks where you can build different things with them. They can be composed with different things. It's just highly reusable. So I'm just going to go through this real quick and install this CFG mod-cron Puppet module that I've already got here on my system using yum so that we can take a look at what it actually installs and what we do with it. So Puppet modules can depend on each other, as I said before. So this CFG mod-cron module had two dependencies in it. It's going to be configuring the cron daemon, and it's going to be, the service itself will be managed by Monet to make sure that cron d is always running. So actually, when I installed that package, you can see in the output of this RPM query, I'm declaring that I depend on cron and Monet, and I also threw a Puppet dependency in there just to make sure we're running at least 3.0 on the node that's installing this. So by doing this, a yum install CFG mod cron will get me all the software that I need to run this thing and for it to configure my system to do this cron job. So currently we install all of the modules to whatever the system standard module path is. In Red Hat's case, that's etc Puppet modules. And we really do this just for simplicity's sake, even though these modules aren't necessarily things that are parameterized or anything like that. Installing them to the system standard module path makes it really easy to include them when we're doing Puppet runs. So this also kind of ties into, we install all the modules that will be applied on any given system and none of them that won't. So we're doing Puppet local applies. We're only going to install the code that we're going to apply. We're not going to install all the Puppet modules that we have, even if we're not going to use them on there. And that actually buys us a lot, and you'll see it'll make a little bit more sense in a second here. So we go with this notion that we always apply all the installed modules on any given system. So it makes it really simple to say, like, I want to install these 10 RPMs that all have runnable Puppet module code in them, and then there's a single command that we use that goes and applies all of them. We need no prior knowledge of what modules are on that system, what roles it should fulfill, or anything like that. So this is just taking a quick look into what this Puppet module installed. You can see that there's really not much to it. This cron module is going to install the monet job into etc monet.d, and this init.pp file is just the manifest that actually goes and handles any of the logic that Puppet's going to apply to the system. So this command here is just showing the code that this installed. This is the init.pp file. The grep is just to get rid of the comments that were at the top of the file, so you don't have to look at that. But you can see it's extremely simple in nature. It's just enabling the service. It's not starting it. And that's actually important for us because at first we got into trying to use Puppet to manage the state of all of the services on the system. And so what we ended up doing was, in our user interface, there was a button that you could click that would disable a certain role of a service. And when you would do that, we had to then go and do a Puppet apply in order for it to stop the service or put it in whatever state it was that we wanted. So we stopped doing that, and we handle that from an external mechanism now, but that's why this enable true is just going to check config the service on. It's not going to start it. And then you can see the second stanza is just a file statement so that we drop our monet.d config into the directory so that monet can start monitoring the service. And actually, since we're using monet, it's important to not try and control the state of the service if it's running or not, because monet is always going to be trying to keep it running if that's what the configuration says to do. So code verification is important, and we get a lot of that, like I was saying before, for free with RPM. It provides code verification by just doing an RPM verify. So this RPM-V is the switch to do an RPM verify, and this is just going to quickly go through all the files that this RPM installs and verify the MD5 checksum, the timestamp, the size, and a couple of other various file operations. So when I ran this, you can see the exit code was 0, and there's no output because I just installed the RPM. There's been no modifications to it. It verifies. But what happens if I do something like this? So this is modifying one of the files that this RPM installs. I'm just appending a new line to the end of the init.pp file. So now with that, if I run RPM verify again, I can see this file has changed, and now my exit code is 1. This is a really easy way to verify that the modules that are doing your configuration management or system verification look like you think that they should. So about applying modules, there's no module ordering. I mean, this has been discussed up and down, left and right in the Puppet community. But basically, when we go to do Puppet runs, we respect this, that there's no module ordering. We handle all of that within the Puppet manifest through requires, before and after statements and things like that. Modules need to be idempotent in the way that they run in order to be able to verify and detect system drift. And what I mean by that is if you have a module that does something like deleting log files, cleaning up after something, an exec statement that runs with refresh only all the time, basically every time that you do a Puppet apply, there's going to be some resource that needs to be refreshed, and you can never get that true state, like is my system in a verifiable state at this time. But by writing modules that are idempotent, you get this drift detection, and it's actually quite powerful in what you can do with it. So again, there's no prior knowledge of installed modules. There's no site.pp file or anything similar that tells us what modules we should apply on any given system. And invoking Puppet should be simple. So I've seen lots of times there's a lot of complexity in invoking Puppet where you have to apply certain modules at certain times. Maybe you apply this set first and this set second, but by keeping it very simple, it opens up a lot of opportunity to orchestrate outside of Puppet. So we wrote this small tool called Puppet Module Runner. It's like a 30-line shell script. But really all it does is it standardizes the way that we run Puppet. So it'll discover any modules that are installed in the system by asking Puppet for its module path and then just looking for any modules that have an init.pp file inside of it. It passes all the names of the discovered modules into the Puppet apply command directly. So this is how we run Puppet without a Puppet master, basically. And it lets you run it in like the normal apply mode or no-op mode. Basically, we use the no-op mode to be able to detect the system drift by applying all of the system modules at the same time. So we came up with this syntax. There's 2 switches. It's pretty simple. Those are the only things that we'll ever run to apply our Puppet modules to any given system. So if I run this on this box, I'm running it with the --test option first. So you can see that now that I have this cron module installed and I ran this with test, you can see these two no-op resource refreshes here. So it's basically telling me what the system should look like according to your Puppet modules isn't so at this time. So then if I run it with the -- apply as expected, it goes and actually writes out those resources. And if you do a -- test again, now you can see there's no configuration drift from what we think the system should look like. So we actually use this as part of our verification story. Applying modules locally is fast and reliable. We've been using it for a while, and at this point, we prefer it to the traditional Puppet Master. We've also used that in the past. It works well with Hyra. So what you lose by doing a Puppet local apply is the ability to parse different things into variable names or do this or do that to get some data from your Puppet Master onto the node. But Hyra really solves that for us because we can push a YAML file or a JSON file to a node, and then we get the same effect by using Hyra lookups rather than just assuming that a top scope variable is set. And you can basically bring your own orchestration tool at this point if you sort of follow this pattern. So we're actually, I think Keith mentioned before, we're using Fabric to do all of our, well, a lot of our deployment today. So we use two main functions. We can use Fabric's push to push a Hyra YAML file to a node, and then we can use the exec functionality of it to go and run our Puppet module runner -- apply. So this Puppet module runner, I threw it up on GitHub just before this conference, just more to demonstrate what we're doing with it and how that can be useful. Check it out. So our overall verification story using these things is, as a systems engineer, I want to detect config drift. That's using the Puppet no-op. Verify the code doing the detection, which is the RPM verify. And I want to also verify all of their installed software on the system, which is also RPM verify. And so I can determine the system state. But basically, we're getting all of this for free with the built-in tools in the operating system, plus Puppet. Those are the only things that we're using for that. And this sort of follows the 80-20 rule. We get 80% of the verification that we really want out of the system with 20% of the effort. So there's definitely things that you can do. It's not undefeatable, but it's pretty good. So the next thing that I'll talk about is how we manage software installed on the systems. In our case, we're using Red Hat, so it's going to be all RPM and Yum based. 2 minutes? I'll try. OK, so writing package statements works for a little while, but eventually everybody gets tired of doing it. Software needs to be updated, verified, and sometimes deprecated, and how you would do that in Puppet sort of varies based on implementation. You don't want to be declaring what you don't want installed all the time. When do you remove that resource from your Puppet manifests? It's hard to say. You don't want to be hand modifying manifests if you don't need to, because it's time-consuming and error-prone. So how can you reliably install software and ensure that you have nothing that you don't want installed on there easily using Puppet? So at some point, the desired system software is known, applications, middleware, and OS. Maybe it's after you've built a virtual machine image. Maybe it's after you did a kickstart. At some point, you know what are all those packages that I want installed on my operating system. So use data to determine installed software. It doesn't have to be a bunch of package statements in a manifest. You should be able to figure out, these are all the RPMs that I want installed, and pass those into Puppet somehow so that you can apply all of them to your system. So we can actually capture a list of software packages and enforce it on the system because we're using a distribution that comes with a package manager, RPM. So package list is a module that I wrote back in November for managing installed software. It's available on Puppet Forge, or you can get it out of my GitHub account. And basically, what makes this thing unique is that package lists are easy to generate. You can use rpm-qa and redirect output to a file, and that creates a package list that you can then enforce. It accepts plain text package names with an optional version, so you can tell it to pull in the latest, or you can tell it to assert that I want a specific version of anything installed. It supports uninstalling packages you don't want, which I'll demonstrate here in just a second. And it promotes declare what you want and not what you don't. So you don't need, using this pattern, you wouldn't need to ever write ensure absent in a package statement. So I'll create a package list real quick. Just like I said, RPM QA redirected into a file. And then you can enforce it just by calling this package list type that this module provides. And I'm passing it the path to the package list file. So you can see it didn't do anything. And that's because I just generated the list. None of the packages on the system have changed since then. But what if I were to do something that was going to cause some sort of configuration drift, like I'll uninstall the unzip package, okay, and then I apply that same package list again, it should figure out that something changed, like you don't have this package on your system that's supposed to be there, so it goes ahead and installs it from your Yum repositories. So purging software, you can also purge all the things that are not mentioned within a package list by passing a purge option. It's disabled by default. If it's not declared as installed, then it should be declared as not installed. Compares the RPMDB against a package list. So basically, after it's done asserting that any of the packages you want are installed, it then asks the RPMDB for a list of all the different packages on your system, and it compares that against the package list you passed in originally. So let's say I'm a developer and I'm debugging some system and I install strace so that I can look at some low-level debugging information. Well, now if I apply my package list to it again and I pass this purge option, it sees strace is on there, but you didn't declare that that's what you want in your package list. So it'll go ahead and remove that for you. So notes on using package lists. You won't have any definitions, package definitions and manifests. I mean, you can, but it would be encouraged that you wouldn't. Packages are still resources in the catalog, meaning you can still trigger events based off of them. Package resources are always added by name so that it's nice and consistent in the way that it does that. And the purge option will also remove any dependent packages because it passes the purge option. So use it with caution. So files are so 1999. How else can I declare a package list? What's up? I tried.